All right, so hopefully you've had a chance to try this one. It says the graph below is that of a cubic polynomial. So we have another cubic function. And it's asking us to write a possible rule. So what could be a possible equation for this? Well, I need to start with the zeros again. And I have a 0 at -6, 0, and 4. And remember, these zeros are the x-intercept. So that's why I'm saying these are my zeros. So x equals 0, x equals -6, and x equals +4. Well, how I'm going to start off writing a rule for c of x is I know that because x is 0, I just have an x on the outside. If I set x equal to 0, it's 0. So that's where x is coming from. And the others, I know are going to end up being two binomials. And when I put them inside, the sign is just going to switch. So instead of being x minus 6, I'm going to have x plus 6 because it flips when I take it out, when I find the 0. And instead of having x plus 4, I'm going to have x minus 4. So I finished finding it in a factored form. And now I just need to multiply it out to find it in a standard form. When I multiply this out, remember, I'm going to start with the two binomials. So x times x minus 4 plus 6 times x minus 4. And this is going to give me x squared minus 4x plus 6x minus 24. And when I combine my like terms, I get x squared plus 2x minus 24. But let's not forget that this x was here on the outside the whole time. So once I'm done with everything on the inside, I can distribute this x inside. And I get x to the third power plus 2x to the second power. See how it's increasing by 1? Because I'm multiplying by 1x. Whereas in the last example, each of them increased by 2 x's because I was multiplying by x squared. And that would be the answer for c of x in standard form.